So today what we're going to do is we're going to do a little revision about angles and the angle properties. Now these are topics that from previous years, so hopefully you remember some of it, but it might take a little bit of review, and some of you might not have grasped it as well as you thought you did, so we'll see. Now, again, we're just going to be talking about basic ideas of angles, so don't freak out, okay? And then we'll expand on that and go into angles and shapes and measurements later, okay? So here we are. First thing, angles are formed where two lines meet, okay? So say we have a line segment from point A to B and a line segment from point A to C. We label these AB and AC with a little line over them. Now notice the little line and the format. This means line segment. You could also have something that is, so notice how it doesn't have any arrows on it, so that means it's a line segment. This is the symbol for a line. It goes infinitely in both directions. Anybody remember what this one is? If it goes infinitely in one direction, it's called a ray.
It's called a line.
Remember that? No? Okay. No worries. And it can go in either direction. Remember, the arrows mean that they go on infinitely. But notice there's no arrow here on the end of either one of those. So what does that mean?
It does not go on infinitely.
Right. It has a definite beginning and a definite end. Okay?
Doesn't that mean it's a line segment?
So this is a line segment. Exactly. Okay? So, right? So if you just have just the line across, then they're line segments. The point here where they meet is an important point. Does anybody remember what it's called before we go to the next slide? It starts with a V. There you go. Excellent. It's the vertex. And the vertex was where the two lines meet. That's what actually creates the angle. Now, there are two angles being created when these two lines meet. We have an angle inside, and if they want you to measure the angle inside, they'll put the little half moon shape in there, the little curvy line. But there's also another angle. Outside, exactly. There's an angle outside, and we'll talk about that.
The inside angle, you can easily calculate the outside angle.
Exactly.
The inside angle from 360 degrees.
Perfect. That's exactly what we're going to do. Okay? So, all right? So, just know that an angle is formed where two lines meet, or two line segments. All right?
What? Can you repeat the whole thing?
An angle is created. Angles are formed. It's just this top sentence here.
Oh, okay.
Angles are formed when two lines meet. Okay? Now notice the naming convention. AC, AC. AB, A to B. Right? Okay? Now there's one other convention. Where if you're naming this angle, this would be angle CAB. And the symbol for angle is just a little angle in front.
Add an A in front of the C.
Okay? Nope.
A cow.
Now,
A cow.
notice which one is in the middle.
A.
A. Why? Anybody want to think about why A is in the middle? Because it's the middle. It's where the angle is. It's called the what? Vertex. So the vertex is always in the middle. Now we can also call this angle BAC. The order of the line segments makes no difference, but the angle, the vertex, has to be where? In the middle. Okay? So the angle, the vertex has to be the letter in the where?
Middle.
In the middle. Always. Good deal.
So A is A.
Write an A in front of the cab.
Not another A. Why? I don't know why she's saying that. This is probably something. No. So here the vertex is the A. Okay? All right. Angles are formed around vertices. And here we go. They're talking about the naming convention. So it's angle BAC. Notice the symbol for angle is just a little drawing of an angle.
Why is it BAC?
Because it could be CAB. Either one. Right? Remember, it doesn't matter. The endpoints don't matter. What is important is what? The vertex is in the middle. So as long it makes no difference which of these two letters go first, as long as this one is where? Shh, guys. As long as this one is where?
In the middle.
In the middle. Okay?
Wait, let me
All right, so here you go. Angle BAC or CAB. And sometimes you just name an angle by the vertex itself, angle A. Now, it's not as precise, but you could definitely do it. If you were just talking about using angle A for something, then you don't care about the rest of it, do you? You're just talking about the angle. All right, but the vertex has to be in the middle. There are lots of ways to measure angles, but in this lesson, we're always going to use what are called degrees. Degrees mean that you're taking a circle. All of this is based on a circle. Even though they're angles, it's based on a circle. And there are 360 degrees in a full rotation or full circle. Make note of this word, rotation. Right? That means you start at one point and go in a circle. Right? A rotation is just a circle. Okay? This is also known as a revolution. So rotation, revolution, it means exactly the same thing. One revolution means once around the circle, okay? Later when you move on and you're doing trigonometry, you might have things like 3 revolutions or 3 pi revolutions and all kinds of... So make sure you just remember that just means you're going around the circle, okay? All right. Good deal. When you think of the angle size, what you're doing is you're thinking of the fraction of the angle multiplied by 360. Nobody does this, but you can. Okay, so for this case, this is 1/4 of a circle. So that means 1/4 of 360 degrees, which is the same as 360 divided by 4, which is how many degrees? 90.
I'm so confused.
Okay, so if you have 1/4 of a circle, that's 1/4 of it. Right? How much is the whole circle? 360 degrees. And the blue part is 1/4 of that. So we just do 1/4 times 360. Remember when you're multiplying a whole number times a fraction, it's divide, then multiply. Good. Keep that pattern in mind. It always comes back to help you. 360 divided by 4 is 90. Times 1 is still 90. So that means this degree is 90 degrees. Uh-huh.
Is it?
Of course.
I didn't know that. I
Yeah.
thought geometry was just triangles and rectangles.
No, angles too. Circles. Okay? All right. So, I want you to look at this graphic because it's a really cool graphic to be able to explain what happens. Notice that if I change... Now notice this is... Which dot is the vertex? The blue one. And so the red and the green ones are the lines. And notice if I move the line, oops, let me get it down a little bit. If I move the line, what happens to the angle?
Becomes bigger.
If I move it that way, it's increasing. But if I move the lines closer together, what happens?
It becomes an acute angle.
Yeah, it
That
gets
means
much smaller. Right, there you go. But watch this.
it doesn't change.
Watch what happens when I move the vertex.
It doesn't change.
It doesn't change. The position, in other words, the position of the vertex makes absolutely no difference. So it can be pointing upward like this, or another direction. It makes no difference. Okay? Now this one changed because I went across one of the line segments. But as long as you're not crossing one of the line segments, the position of that vertex makes no difference. The angle stays the same. But moving the endpoints does change the angle. Okay? Either smaller or larger.
Can you make it into a straight line?
Okay?
Make it into 90?
Oh,
No, make it into 180. Can you do that?
well, no, not on this
Can you
thing.
make
It
it into
won't.
360?
It won't let me.
360.
No, because it's 3 points, so it won't let me do that, guys. Okay. All right. Oh, sorry, that's your homework. So, okay.
Why?
Now, angles. Yes, homework. Angles are classified by their measurements, and there are several of them that we're going to look at. And the first one that they look at, and it doesn't matter which way you look at it, the first one they look at is something called an obtuse angle. Obtuse angle is an angle between 90 and 180 degrees. 90 degrees is a very special angle. Right? So you get a little square inside. That's a 90-degree angle. So obtuse angles are between 90 and 180 degrees. Okay? A straight angle, which seems a little odd to call it a straight angle, but a straight line is also an angle. A straight angle is equal to 180 degrees. Half a circle, right? Because if you drew a straight line straight through the middle of a circle, then it would cut it in half. Okay? So we have obtuse and straight. Obtuse means what? Between 90 and 180. Straight angle means what? 180 degrees. Good. A reflex angle is anything bigger than a straight angle up to the full circle. So a reflex angle is between 180 and 360. Notice this one is, we typically measure angles on the inside, but reflex angles are on the outside. They're the big part of the angle, right? The bigger part.
Angles are kind of like fractions if you think about it.
Yeah, because they're just parts of a circle. Exactly. A revolution is equal to 360 degrees. So there's that word, revolution, right? So that tells, a revolution is just a full rotation, but if you're calling talking about an angle, then we call it a revolution. It's the entire 360 degree circle. So let me start at one point, go all the way around. Some of this, remembering some of this, I hope. Okay? All right. Uh-oh. Did I skip a slide? I must have. Ah, here we are. I did. We have what are called acute angles. That means they're between 0 and what? 90 degrees. Acute little angle, right? So little baby angles. There you go. And a right angle, which is incredibly important to understand, is a 90-degree angle, right? And notice that it has this little square in the middle. That tells you, at the vertex, that tells you that it's exactly 90 degrees. Because if you have a square, all the angles of a square all are 90 degrees. Okay? They don't have to tell you that, but in order for you to assume it's a right angle, they either have to give you the box in the middle or they have to tell you it's 90 degrees. Do not assume that it's 90 degrees unless they give you one of those notations or you measure it. Okay? Because there are lots of angles that look like 90 degrees that aren't. So be careful. In geometry, they like to mess with you with that. Okay? So, here we go. Obtuse, reflex, etc. So let's just go through a couple of these. Which of the following describes an acute angle? Between 0 and 90. Exactly. I know you always make me check my answers because you don't like it if I'm giving. Which of the following describes a reflex angle?
360.
Yeah, 180 to 360. It's the biggest one, right? Well, not the biggest one. What's the biggest one? A revolution. There you go. Good job. Okay. Which of the following describes an obtuse angle? There you go. Okay. Right angle? Equal to 90. That's a very specific one. Okay. Which of the following describes a straight angle? Equal to 180. Oh, we know they're right. Which of the following describes a revolution angle? There you go. Okay. Which type in the zone below? Acute. Okay. There you go. We're not going to talk about any more of those because... All right. Now, here is some of the math that you may or may not remember. But again, we're going to talk about it just a bit. The first idea we want to talk about is this idea of complementary angles. And if you look at complementary angles, what are the first two letters? C-O, right?
Yeah.
Which are also the first two letters in the word corner. Exactly. Complementary angles always form a corner, in other words, a 90-degree angle. So, when angles sum to 90 degrees, we call them complementary angles. So, and it doesn't say two angles. It could be 3 or 4 or 5. It doesn't matter as long as they sum, which means add, right? As long as they add up to make 90 degrees, they are complementary, right? Okay. Now, another thing that we want to talk about we'll talk about some notation later. So they're calling this one angle A and this one angle B. What do we know about those two angles? Because they're in this little They're complements of each other, which means that if you knew what they were, they would add up to make 90 degrees. Okay?
It looks like one's 50 and one's 40.
I would guess 25 and
No.
Yeah.
Well, maybe 55
Yeah,
and...
this looks a little smaller. I would say it's probably
25
that
or
25 or 30 somewhere in there. So doesn't matter. When two angles when angles sum up to or add up to make 180, a straight angle, they're called supplementary angles. So you have complementary angles and we have supplementary angles. Now in the States, we always do that because we say that supper is the biggest meal of the day, but y'all don't call it supper, do you? Anyway, so supper is the bigger one. Anyway, moving on. Okay, but supplementary is the big one. So the angles add to make 180 degrees. So angle A and angle B here, if you added them together, you would get 180. Now this is important because if I knew one of them, I could find the other.
easily.
Yeah. So let's say that angle B was 100 and what?
110.
110 degrees.
That's one.
Then that means
1,100. That's 1 0.
I got that's a degree. That's a degree.
Okay.
Yeah. All right. So I can just take 180 degrees minus 110 degrees, which gives me 70 degrees for the other angle. Now, again, those are made up numbers. That's not what the measurements are. We just made it up just as an example. But okay, but they certainly could be.
I tried to think about
Okay? Now, notice this all the way down. Those degrees are the units for these angles, so you must include them. If you drop it off, then the answer is completely wrong. Because it's not 70. It's 70 what? Degrees. Okay? So be careful. Mm-hmm.
Do you mean like the degree symbol has to even be in the working out? Like
Absolutely. Just like yes, I will insist on units in your working out. It's probably got, if you're working here, they'll have a little box for it, somewhere for you to put it in. Okay?
Okay, good.
All right. Let's see. If you have all the angles in a circle, they all add up to 360. They are called a what? Revolution. You make one full revolution. Exactly. So now, it doesn't have to be 3 angles, but if you cut it, if it's 2 angles, it's always going to be the same. Why? Because if you cut a circle with one line, it has to be 180 to 180 degree angles. Good. Okay. So revolution.
But Mrs. Self, isn't it really perfect? Can you actually leave these like things open? Like, instead of,
Yeah,
like,
if you want to.
sections?
I can. Vertically opposite angles. So if they're opposite, and they call it vertically opposite, but if you look at A and B, those are actually not vertical. They're horizontal. It's called vertically opposite, but it doesn't matter. They're just opposite angles. Opposite angles where 2 lines intersect are always equal. So angle A and angle B are equal.
I don't know how to write
Okay?
that down.
So you can write it down by saying angles that are opposite of each other, vertically opposite angles, are equal. So it doesn't matter how you cut it. Notice my lines are much bigger than theirs, much more spread apart. It makes no difference. Angle A and B are going to be the same. It can't not happen. Now, because you're going through the center of the circle. If you didn't go through the center, then you could get from some different kinds of angles. But when you're crossing it, you have to go through the circle. Okay? So opposite angles are what? Equal. Okay? So if I know A is 40 degrees, then what's B?
40 degrees.
There you go. If I know D is whatever degrees, then what's C? Whatever degrees. Right? The same. Right? Angles opposite each other are always equal.
Then whatever degrees.
Okay? All right, whatever degrees. Well, because B stands for some unknown number. Oh, okay, there we go. So into your homework, I'm not doing that.
Oh, but are you
Oh,
sure?
dang.
And there you go, your introduction to angles.
Are you
So,
sure you don't want to sound like you know it's right?
let's just recap.